Okay, so let's do an example. We just saw some terminology. Okay, now an example. So here I said, okay, let's toss a fair coin 2 times. When I say fair, it basically means it's just as likely for the coin to land heads up than it is to land tails up. You know, both outcomes are just as likely. But you're tossing a fair coin twice. Then the sample space would be, let me get that laser thing. This would be your sample space. You can get heads first, then heads on the second toss. You can get the coin could land heads up, then tails up, then heads up, then tails up and tails up. Those are all the possible outcomes from the experiment. And any one of these actually would be a simple event. So the coin lands heads up, then tails up here. That would be a simple event. You can't break that down any further. Remember, the experiment is tossing the coin twice. Or something like, you know, the coin landing tails up and tails up. You get tails twice. That's another event. Okay. And other events you can get, like for instance, maybe the coin lands tails up only once. Well, that would be an event you can break down, because how can that event happen? You can get heads then tails, or tails and heads. Or another one could be that the coin never lands tails up at all, although that would be a simple event. But anyway, that would be some events you can get. Okay. So here's another example of rolling a die, a fair 6-sided die. So each side of the die is labeled with a number, one of these numbers. And some simple events would be, you know, you roll a 1 or roll a 2. Those are events. Those are simple because you can't break them down. You can't break them down any further. You know, rolling a 1, for instance, right? You know, you can only roll a 1. There's only one way to do it. Same thing with rolling a 2. But if I were to say but the event where we roll a number larger than 3, you can break that down, because we can do that by rolling a 4, a 5, or a 6. Or rolling an even number, right? We can roll a 2, 4, or 6. That's also not a simple event, because you could break it down. All right, so those are some examples. Now, let's get to the actual definition. Well, here we're going to assume that all outcomes are equally likely. Okay? Now, when you have an event, simple or not, it's denoted by a capital letter, like E, for instance. I mean, what's actually happening is it's a set. Sets are denoted by capital letters. I don't want to go too much into set theory, because I have to. The probability of an event occurring, it's denoted by this, P of E. And by definition, it's the number of outcomes in event E or corresponding to event E. And then you're dividing by the total number of equally likely outcomes. So again, it's the total number of outcomes corresponding to set E, and you're dividing it by the total number of equally likely outcomes. That's what the actual definition is. So as you can see, it's going to be a fraction. So let's do some examples. Here's our first one. So again, we're rolling a 6-sided die. And it's a fair 6-sided die, I should say, meaning that each of the outcomes here in a sample space are equally likely. They're all meaning all the outcomes are equally likely. Sorry. So first question is, we saw it already, is what is the sample space? Well, again, that's all the outcomes, right? Each side you have an outcome, 1, 2, 3, 4, 5, 6, and they're all equally likely. So you're just as likely to roll a 2 as you are to roll a 5. What's the probability of rolling a 2? Well, so this event would be rolling a 2. Well, how many outcomes correspond to that? Well, there's only one, rolling a 2. That's why the numerator here is 1, right? The number of outcomes corresponding to the event. Here is just 1. How many outcomes are there altogether? There's 6. You're rolling a number and you're recording that number. So we get 1/6. Right? So that's what we're doing. We're rolling a die and we're recording the number. I mean, I didn't write down we're recording the number, but I think that's kind of given. Now, what about rolling an even number? Well, in that case, how many numbers are even? Well, how many outcomes correspond to that event? There's 3. We have 2. Right? Number 2, we have 4 and 6. So there's 3 outcomes corresponding to that event E, right, which is rolling an even number. There's 6 outcomes altogether, so we get 3/6. We have that. Here's another example. Now we're going to assume we're rolling a fair 12-sided die. Fair meaning, again, they're just as likely to any of the outcomes, any of the sides can be rolled. Any of the numbers on it can be rolled. Hope that makes sense. I think it does. So what's the sample space? Well, each side has a number, right? So we have these numbers as the sample space. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, I don't know if there actually is a 12-sided die, but again, we're just assuming hypothetically there is one. Now, what's the probability then of rolling an 11? Well, okay, so the event would be rolling an 11. There's only one outcome in that event, right? Rolling an 11. We have a 1. And there are 12 outcomes altogether in the sample space. So it'll be 1 out of 12. I mean, originally here I made a mistake of 1/6, but it's 1/12. What about rolling an odd number? How many odd numbers are there? Well, you have 1, you have 3, you have 5, you have 7, you have 9, you have 11. So there's 6 numbers, I said. So it's 6 over 12. Right? How many ways can this event occur? 6 ways. We roll one of the odd numbers. How many outcomes are there altogether? 12. That's what we get. Okay. Rolling the die once, right? The sample space is all the outcomes you get. So that's what we get here. Okay. All right, so we have that. Now, what the book goes into next is what a deck of cards are. And I just, want to do the same thing they're doing, basically clarify what a deck of playing cards are. I mean, you don't have to buy a deck of cards. You can if you want to, obviously, but you don't have to. A standard deck of 52 cards, right? Well, there's going to be 4 suits. Each of the cards will have a suit, will correspond to a suit, and there's 4 suits. There's spades, diamonds, hearts, and clubs. Okay, those are the 4 suits. And in each of those 4 suits, you have 13 cards. Namely, you have the cards that are numbered 2 through 10, okay? Numbered 2 through 10. Not only that, you have what are called face cards. You have Jack, Queen, and King. Those are face cards. And then there's an ace. Now, is the ace how do I say it? Does the ace rank above a king or below 2? I think that depends on the actual situation. But for now, these are the cards, and that's all we care about. There's no jokers in the deck, is what I'm saying. So there's 52 playing cards, 4 suits, 13 cards each suit. And each suit has 3 face cards. Okay. That's what a deck of cards look like. Well, I want to do an example with that, but first let me change the recording.